How's it going, guys? I want to post this up really quick. This is your second review that we worked on in class today, so let me go over it really quickly here. This is number one, the tangent of 105. Okay, so I'm going to say this is the same thing as the tangent of, let's say, 60 plus 45. That should make 105. So I'm going to say then that's going to equal the tangent of 60 degrees. This is in your formula chart, plus the tangent of 45 degrees over 1 minus the tangent of 60 degrees times the tangent of 45. Okay, so I'm going to take a quick look over here. So let's just change my marker very quick here. And I'm going to make a 60-degree angle right here. So something like this, and this is 60 degrees, I say. And I'm going to make another one next to it to represent 45 degrees, which is right here. Okay, so what I'm going to do is go ahead and label that my 30, 60, 90 triangle. We'll have sides of half and root 3 over 2. And this one, the 45, will have isosceles right triangle, so it's a square root of 2 over 2, and the same here is square root of 2 over 2. Keep in mind that some of you had questions on this, that this right here, the y value is the sine value, okay, of that angle, and right here is the what is the cosine, and the same thing go over here. So let's go ahead and resolve this problem here. Let's switch to blue, I think. Yeah, okay. So I'm going to ask, what's the tangent of 60? Well, 60 degrees here is right here. We're going to say it's going to be this y divided by this x. So we're going to say root 3 over 2 divided by half. What happens is these 2's will cancel out, and basically what I have is root 3. That's all I'm going to have. Root 3, and then plus tangent of 45, it's this divided by this, so something divided by itself is 1. So that's what I have on the top here. I have 1 minus tangent of 60. Again, I told you tangent of 60 is root 3, and then the tangent of 45 is 1. So this is root 3, and this is 1. So just this times this is just going to be root 3. So that's what I have here going on, and then I have to do something with that. So I'm going to multiply the bottom of this by the conjugate, I guess we call it, of this. Okay, of the bottom. And the reason I'm doing that is because I'm going to actually get rid of the radical, okay? And I'm going to actually work out all the steps by foiling this out, but technically you shouldn't have to as you practice with it. So I say root 3 times 1 is root 3. Root 3 times root 3 is just 3. 1 times 1 is 1, and 1 times root 3 is another root 3. That's what I have on top. I have 1 times 1 on bottom, 1 times root 3, which is root 3, negative root 3 times 1, which is negative root 3, and negative root 3 times root 3, which is negative 3. So this is what I'm going with. I'm going to change this up here. Let's get black pen, I guess. All right, so I have 3 plus 1, so that's going to give me 4. And then I got root 3 and root 3, so that's 2 root 3. On the bottom, these will cancel out the middle terms. That's the whole point of having one of these is minus and one of these is plus. So we're going to say, let's cross out. 1 minus 3 is negative 2. Okay? And what I usually like to do is split this into two different fractions. I'll say 4 over negative 2, and then I'll say plus 2 root 3 over negative 2. And then what I'll see from this is that 4 divided by negative 2 is negative 2, and this divided by this will give me negative root 3, and that will be your solution. And that's the answer to that question. That's about all there is to it, really. Not such a big deal. Let's do sine. All right. So the sine of this is going to be sine of 300 for me plus 45. And again, I like to emphasize that there's a lot of different combinations of unit circle angles you can use to sum and difference wise to get this answer, to get 345. So this is not the only way to do it. Okay, I kind of want to stress that because some people think, okay, I didn't do it that way. That's okay. You don't have to do it the same way that I do it. All right, as long as you get the same answer, that should be consistent. All right, so I'm going to look at this. I have the 300 angle, which is right here. It's going to be about right there-ish. And I'll say this angle here is 300 degrees. Well, if I go 60 further, I'll get to the full circle, 360 degrees. So I'm going to say this angle right here is 60. All right. And what I have here is a 30, 60, 90 triangle. And this is a half, and this is negative root 3 over 2. All right, switch back to colors that rhyme with purple. And I'll say, okay, let's try the 45-degree angle. It's about right here. Okay, and then I will evaluate the sides of this right triangle. This is going to be root 2 over 2 again, and root 2 over 2. Again, it's exactly the same as the one we had up here. All right, so let's actually figure this out. This is going to be given as the sine of 300 times the cosine of 45 plus the cosine of 300, oops, and then times the sine of 45. Okay, so that's what we're going to do. And let's just figure this out. So the sine of 300 right here is going to be this y value, which is root 3 over 2. The cosine of 45 is this x value, which is root 2 over 2. Okay, this is a negative root 3. I didn't really put that, need to emphasize that's a negative root 3 over 2. That's a negative value. Very important that you don't forget that, because it'll be wrong if you do. Cosine of 300, this is going to be a half. And the sine of 45 is root 2 over 2. So I have a negative 3. Remember, that's a negative. Times root 2. Negative root 3 times root 2. That's negative root 6. 2 times 2 on the bottom is 4. I got 1 times root 2 over here, so that's root 2. And then 2 times 2 is 4. And don't forget there's a plus sign in between them. So now that I have a common denominator, I can write this as negative root 6 plus root 2 all over 4. Or I can write it as root 2 minus root 6 all over 4. Either one of these will give you the answer. It's the same. Okay, I just prefer to put the positive term first. Usually it's my preference, but it doesn't mean it's wrong to do it this way. Okay, verifying trig identities. Okay, yeah, this is a lot of fun. What we're going to have here is two fractions that we need to add together. And as we learned in middle school, you can't really add two fractions together unless you have a common denominator. So the only way I can really achieve this is to actually multiply this denominator by this one. Okay, so I'm going to multiply cosine by 1 plus sine. I'm going to do it over here. 1 plus sine. Okay, I'm just going to multiply these two together. But if I multiply this by the bottom of the fraction, I have to multiply it by the top as well. Because if I don't, I'm changing the actual problem, and I don't want to do that. So I know full well that 1 plus sine of x divided by itself is actually the same thing as 1. So it's kind of like multiplying this fraction by 1. It doesn't really change it. That's why we can do this. So I'm going to multiply 1 plus sine by the other one, which is cosine of x. And I'll multiply top and bottom that way, okay? Here and here. All right, so let's just go through that. I'm actually going to FOIL this out. I'm going to say 1 times 1 is 1. And then I'll say 1 times sine is sine of x. And then I have sine of x times 1, which is sine of x. And then sine of x times sine of x, which is sine squared x. And I'm actually not going to multiply these. I'm just going to leave it as it is 1 plus sine of x times cosine of x. I'm just going to leave it like that. I'm actually not going to multiply that out. Okay. On here, on this side, I have cosine times cosine, which I know is cosine squared x. And then I'm going to leave this the same as well. All right. So what I now see is I have a common denominator, the same bottom part of each fraction. So I can make this a single fraction if I wanted to. I can just write all of this as one fraction. So I'm going to go ahead and do this. I'm going to change it to red here. I'm going to say I have 1. Okay, 1. And I'm going to add. I have a sine x and a sine x, so I got 2 of them. 2 sine x. And then I have a sine squared. And then I have the cosine squared. And then I have the same thing on the bottom, just the common denominator, which is 1 plus sine of x times cosine of x. All right. Now let's see if we can clear this up a little bit. So I can see here something really nice and convenient. This bit right here. Sine squared x plus cosine squared x is a very well-known Pythagorean identity. This is actually the same thing as 1. So what I have here is 1 plus 1, which I know is 2. And then I'm going to add what's left, which is 2 sine of x over the same denominator. Not really changing that. And for a reason, I'm not doing that. Okay, I'm going to factor a 2 out of this. So I'm going to take a 2 out of the top. So it's 2 times 1 plus sine of x. It stands to reason that 2 times 1 is 2, and 2 times sine of x is 2 sine of x. So I just factored the 2 out. On the bottom, I have the same stuff for the final time. And the reason I say it's the final time is because this right here and this right here are going to cancel out. So what I have now is 2 over cosine of x, which is the same thing as 2 times 1 over cosine. And 1 over cosine is secant, so it's basically saying 2 times secant, in other words. Okay, and you can go from here to here. That's that's pretty intuitive, just going from here to here. So as I see, after all that work, what I have here is the answer. That's what I wanted. Okay, so that's all there was to that one. And let's jump down to the last one. Now, there's an egregious error here that I put on the paper, and I discovered it during first period, so I have to apologize to my first period class again. Because we started working this out with this wrong. This is incorrect to put this because we're just going in circles. So sorry to put you through that mess here. What we have here is actually, this is supposed to be a cosecant. So when I typed this, I made a mistake there. So let's actually work it out properly. So I'm going to change this to a cosecant. So if you haven't done that on your paper, please do. Otherwise, this is not going to make a lot of sense. So I'm going to change it to a cosecant, and I'm going to try to make the left side look like the right side, okay? Just manipulating the left side. So I'm going to have to call upon a well-known rule called the difference of squares from Algebra 1 and Algebra 2. And this is going to be a squared minus b squared is actually equal to a plus b times a minus b, okay? And what I see here is I kind of got that happening here. I have an a and a b that's being squared. I just have to identify what a is and what b is. But I know if I square cosecant squared of x, that I'll get cosecant to the power of 4 of x. So what I'm basically saying is that this a squared is the same thing as the cosecant squared of x, and then I am raising it to the power of 2, just like I'm raising a to the power of 2. So a itself is actually equal to cosecant squared of x. Now I'm going to subtract b, and I see that same thing is going to happen here. It's going to be the cotangent square of x right here, and I'm going to raise that to the power of 2. So if I multiply this by itself, I will in fact get cosecant to the power of 4, and if I multiply this by itself, I'll get cotangent to the power of 4. So just be aware of that. So I'm just going to follow this through with this. So a is what? Is cosecant squared, and b is going to be cotangent squared. So it's going to equal this, what I have here. So I have cosecant squared, and then plus the b, which is what? Cotangent squared. And then this is going to be multiplied by, again, a is cosecant squared. And then minus b, which is minus cotangent squared. Now what I notice right away, if I'm paying attention, is that this right here is the same thing as my answer. These are the same. So that means this has to multiply by this to get itself, which means this apparently has to equal 1. Okay, this part right here, it has to equal 1. But I noticed something. I noticed that the cosecant and the cotangent, this is related by a trigonometric identity. It's a Pythagorean identity. It says that cotangent squared x plus 1 is actually equal to cosecant squared x. Sorry, cosecant squared x. So if I subtract 1 from both sides, or even subtract cotangent from both sides, it stands to reason that 1 is in fact equal to the cosecant squared of x minus the cotangent squared of x. This is actually true. So for this reason, I can declare that this is the same thing as what? As 1. So 1 times this will give you this answer. So basically, that's all there is. Okay, after all that, there's not much to it. We're just saying this is 1 by this identity right here. and therefore this is gone, and it turns to 1, and 1 times this is this again. So that's done. All right. All right, so let's go on to the next question. All righty, down to the triangles we have to solve here. Okay. So let's see. ABC is a triangular field of horizontal ground. The lengths of AB and AC are 70 meters and 50 meters respectively. The size of angle BCA is 78. All right, that's fantastic. So first thing I'm going to find, it's going to ask me, is to find the size of angle ABC. So if I go from A to B to C, this is the angle that they're referring to. Okay, it's the same thing as angle B. So we're going to find it. All right, no problem. So what I'm going to call upon here is the law of sines. If I have an angle and its opposite side anywhere on the triangle, I should try the law of sines. It's not a bad idea. So I'm going to say, okay, I have this angle and its opposite side. So I'm going to say the sine of that angle, the angle that I do know, which is 78 degrees, divided by its opposite side, which is 70, will equal the sine of any other angle divided by its opposite side on the triangle. So the one I'm after is B, so it's equal to the sine of B over its opposite side, which I know is 50. So this is called the law of sines, and I'm going to actually try to use it to find angle B. To get rid of the 50, I'm going to multiply both sides by 50 of this equation. It's going to actually cancel these 50s out. So sine of B is equal to this. Now all I have to do to get B itself is to get rid of the sine, and I'll use the sine inverse to do that. So I'm going to say B, the angle B itself, will actually equal the sine inverse of this part right here. Okay? 50 times the sine of 78 all over 70. Okay? So I took the sine inverse of both sides. That's kind of what I'm doing. Sine inverse of both sides. And this sine inverse and the sine will cancel out. So B is simply equal to whatever we have over here. And that's what this is. So I just get the calculator out and find that answer. All right. So let's go ahead and do that. I'm going to say, first thing you should check here, I'm going to actually clear this page here. Or just make a new page here. And the first thing I definitely want to check is, before you do anything, is to go to Doc and check my settings and make sure that I have this in degree mode, because if I don't, it's going to be quite unfortunate because my answers will start to be way off. So what I'm going to do now is go to Trig. I'm going to say sine inverse, hit Control Divide to make a fraction, and then I'm going to say, what did that say? That said, it said what? It said 50 times sine of 78 over 70. Okay. All right. So 50, let's go back here, times the sine of 78 degrees all over 70. So this is going to give me 44.32. I want to say 44.3 is going to be my angle that I'm after. So angle B is 44.3 degrees. So that's this angle right here. It says 44.3. All right, find the area of the triangular field. So there's a very specific formula that we tend to use in these situations for the area of a triangle. And it's related to, it's the same thing as the base times the height, 1/2 the base times the height. But we rewrite that formula as being 1/2, I'm going to say BC times the sine of A. All right, so let's kind of disseminate this and say, well, okay, well, this is angle A. So the side opposite angle A is little a. This is angle B, so the side opposite that is little b. This is angle C right here, so the side opposite that I'll call it angle C. I mean, sorry, side C, not angle C. So angle C and side C. So big C we'll call it and little c. All right, so what I'm going to tell you then is just plug in what you know. I know 1/2, obviously that's pretty straightforward, but B is going to be called 50. And C, I'm going to call that 70. And then sine of angle A. The only trouble is I don't really know what angle A is, okay? But I do know something. I do know that all the angles have to add up to 180. So technically angle A right here is actually equal to 180 minus 44.3 and then minus 78. So I'll just go ahead and figure that out in the calculator real quick. What is that? Okay. So I'll say 180 minus 44.3 minus 78. So that angle is apparently about 57.7 degrees for the purposes of this problem. So, okay, I'm going to say then that the sine of that is 57.7 degrees. We're going to say the sine of that angle. So this angle that I don't know is now 57.7 degrees, and I needed that for A, and A I decided is going to be that. So if I just type this bit right here into the calculator, it'll tell me the actual area of the triangle that I'm after, right? So let's go back to that, keep using that calculator. So I'm going to say control divide 1/2. All right, times 50. All right, times 70 times the sine of 57.7, the angle I just found, and it's equal to this. So that's the area of the triangle. Looks like it's 1,479.21 cubic meters. I'm sorry, square meters. Square meters. So we're going to say that's going to be 1479.21. 1479.21. That's square meters based on the units that I have on my triangle. All right, so we're kind of going through that. All right, and there's not such a big deal here. Now it's telling me M is the midpoint of AC. So here's from A to C, and M is right in the middle. That's fantastic. Find the length BM, so the length from here to here. Now, I told you, I think I said you could assume this is a right triangle, but that might have been erroneous in class, so I'm actually not going to assume that, and I don't need to, really. Because I know it's a midpoint, though, one thing I can say for sure is that these two sides right here are now the same, so they're half of 50. So this is going to be 25, and this is going to be 25. That's something I can say for certainty, but to tell you this is a right angle may or may not be true. You can't really assume that's a right angle, so I'm not going to. I'm going to say that's a side that I know this angle, I know this side. So I have a side, this side, angle, and side. So a side, angle, side, triangle, and I'm actually going to use a law of cosines to figure out what this unknown side length is. And that will be a true statement for any triangle. If it's a right triangle or any other type of triangle, it still works. If I assume it's a right triangle and it's not, any answer I get will be wrong. So if I use a Pythagorean theorem, it's going to give me the wrong answer. Okay. If I use a trig identity, like in a trig ratio, like sine, cosine, or tangent of this angle, assuming this is a right triangle, that answer is going to be wrong. So this is basically a way that it's going to be true, irrespective of what type of triangle we're actually looking at if we're not sure. So this is the way of playing it safe. So I'm going to say then, use the law of cosines. So I have angle A. I'm going to call this angle A here. And I know that's 57.7. So the side that I want here, opposite that, is going to be called little a. That's my new little a right here. Okay, so I have angle B. I'll call this angle B. And this 25 would be my little b. And of course here is my angle C, I'll call it. And then this will be little c right here, which is still 70. So I'm looking at this type of triangle here. And I got my A, B's, and C's. So the law of cosine says that A squared is equal to B squared plus C squared minus 2BC times the cosine of A. Very well. So let's use blue. So I'm going to say A squared is equal to B squared. And remember, B for me is going to be this 25 right here. Squared. C, I told you, is 70. And then minus 2 times 25 times 70 times the cosine of the angle A that we know, which is 57.7. So we're going to use all this to get A squared. Once I find that, I'll take the square root, and I'll actually get this unknown value that I want for the answer. All right, so we have 25 and 70 to worry about. So let's actually get the calculator open. And we'll say, all right, let's get this going. 25 squared plus 70 squared. I like to use parentheses when I'm squaring things. Minus 2 times 25 times 70 times the cosine of 57.7 degrees. This will give me this, and then remember, that's not the answer for A, that's A squared, so I'll have to take the square root of that. So I'll say a control divide, and then I'll hit control minus. That'll give me the answer to the previous question. So I'm going to put this into the square root, and I'll hit enter. So this distance here is actually 60.45, okay? That's the true answer, irrespective of how else you might do it. This is assuming that this is not a right triangle, and I think that's what I did in class, and you shouldn't do that, okay? I probably won't give you a question exactly like that anyway, but just to be on the safe side, if you're actually watching this video, good on you, because this is going to be a saver for you so you don't make this mistake. So I'm going to say A here is going to equal 60.45 meters. All right, that's what this is. All right, so that's that distance here. That's for sure. That's definite. Okay, so we got that. Final part of this whole thing is we have a vertical mobile phone mast, and it's built next to a field with this base. The angle of elevation from T from M is 63.4. So actually what you should take notice of is that this triangle that we've just been working with up here is exactly the same as this triangle that we have down here, okay? They just added one extra component and they gave me an angle of elevation. So if I'm standing on this point M and I'm looking at point T, just looking up at it, I'm looking up at this angle of elevation, 63.4. So what they're going to tell me then is N is the midpoint of the mass. So it's right here in the middle, N. And what they're going to ask me for is to actually find the angle of elevation here if I'm looking only at a halfway point, okay? So I want this angle. Now, it's logical to assume that because this is the midpoint, that this angle should be bisected, and this should be exactly 1/2 of what I'm expecting it to be. But again, I'm not going to assume that, okay? Let's say I'm not sure what's going on. I won't assume that, and I'm going to play it safe by using my laws of sines and cosines just to make sure that I'm doing everything correctly, okay? Because usually if you're jumping to the simple answer, that's probably the wrong answer, so you have to be careful. All right, so what I'm going to do here instead is I'm actually going to figure out the height of this tower, because I actually want to know how high above the ground this point N is, okay? But I need to figure out the height of this entire tower. So I'm going to do that by making this a right triangle, because this will be true. The tower is vertical. It's a vertical mast, it says. So I can say this is a right triangle. So I'm looking at this triangle right here, the big one, and I know this angle here is 63.4. So what I don't know is the height, this entire height for this whole thing. So I'm going to say then that the sine of 63.4 is actually equal to that height, which is the opposite side, over, well, I can't say sine, can I? That doesn't make sense to do that, right? Because I don't know the hypotenuse. I actually don't know this hypotenuse, so I can't do that. But what I can do is tangent. Let's see if I can get my eraser working. This is usually about the time this thing freezes. Okay, so let's take a look at that again. Yeah, kind of got frozen there. So what I'm going to say then is, because I know this angle here, and I'm saying this is a right triangle because this is a vertical tower, and this is the ground, okay? We're going to say then that the tangent, instead of the sine, we're going to say the tangent of 63.4 degrees is equal to the opposite side over the adjacent side. The opposite side is h. I don't know what that is, but it's going to be h over this adjacent side. And I know this adjacent side is 60.45 because we found this from the previous question, because this is the same triangle as the previous part of this question. So this is 60.45. And what I'm going to say now is if I multiply both sides of this equation that I've just made by 60.45, what happens is if these cross out, and now I have h is equal to this. This will tell me the height of the actual entire tower, which is nice to know. So I'm going to say, okay, let's actually figure out what that is. So I'm going to say, all right, h then is going to equal, let's get the calculator out, 60.45 times 63.4. All right, so 60.45 times the tangent of 63.4, tangent of 63.4. So that's going to be 120.7, okay, about meters. So this unknown height here is actually 120.7 meters. If this is only halfway to n, that's going to be exactly half of that. So I'll just divide this by 2. And of course, I can do that very quick in the calculator since I already have this answer. So I'll just hit Control Divide. On the top, I want the answer from the previous question, so I hit Control minus, and I'm just going to divide this by 2. And that's going to give me 60.35, okay? Or 60.36, we'll call it. So this distance here is 60.36, is what I'm telling you. And now I can calculate this angle of elevation right here from looking at n from m, for instance. And that's what they want, to calculate the elevation from n from m. So now I have that. So I'm going to say, okay, now I have this opposite side and this adjacent side. So I'm going to say this angle here is what I want. That's what they're asking me for, that angle. So I'm going to say theta is the angle, this angle right here. I'm going to say that the tangent of that angle theta is actually equal to the opposite over the adjacent side, which is now 60.36 divided by 60.45. Okay? Now, I'm not really interested in the tangent of the angle. I actually just want the angle. Okay, that's what I'm really after. So I'm going to get rid of this tangent on this theta here by taking the tangent inverse of that and the tangent inverse of this, both sides here. Okay, so this tangent inverse and this tangent will kind of go away. That's how it works. We have a theta now that's equal to the tangent inverse of this. So this is going to just give me my answer for the angle that I want, my angle of elevation here. So it's going to be the tangent inverse of 60.36 divided by 60.45. So I'll hit tangent inverse of 60.36 divided by 60.45, and I'll have the answer. Oops, make sure you type it in carefully because I am careless. All right, so I hit enter. So that angle of elevation is apparently 44.96 or 45 if you even call it that. It's almost 45 degrees. We'll say 44.96 degrees. All right, that's this answer right here for this, okay? So that's that angle of elevation, and that's your final answer for this, and then you're done with the whole thing. You should take notice of the fact that 44.96 is not half of 63.4, like some people are saying, okay? Please be very careful that some of these geometric properties are not well understood, apparently, so we need to be careful. But I will, this last question here was actually an IB Math Studies question, and I will post the actual posted solutions from the baccalaureate program for this question, so you can actually see that these answers are correct. So anyway, I hope you enjoy watching, and your test will be a similar link to this. It's not going to be very long, but the questions will be similar, and should be a pretty adequate representation. But I wish you the best of luck, and I appreciate you watching, and good luck tomorrow. So I just want to switch back to the answer document before I quit, actually, so that you can see that the final answer for that is 45 degrees, okay? Which is about what we had here when you round up to 45. So that was the answer for that. Here are the rest of the answers for that question. These are the official answers from the IB that you can see for all of them. So yeah, that part of the question, part D there, the answer is 45 degrees. If I go back up to here, this will give you the answers for the top half, okay? So we already set this up. We got these answers already. As you can see here, we got this for the area, and of course we got this for the BM for that top part. So I'm just confirming that these are in fact correct and these processes are correct. So that's that, and that's the final answer for the whole question. Anyway, I just wanted to confirm that, but thank you for watching. I hope you got something out of this, and good luck on your test tomorrow. I'm pretty sure you're going to do really well. So